Hi, everyone. This is Jules Urbach, the CEO of Otoy, and today I'm here to talk about the future of rendering at GTC 2022. So this happens to be, I believe, my 14th GTC. I've been doing these for about a decade plus and started out back in 2009, 2010 talking about the future of GPU rendering. And at the time, that was something that was controversial for final frame rendering. Today, I think we've really shown that both in the cloud and on-premise, GPU rendering is here to stay. And it's, in fact, the future for all kinds of graphics and production work. And our mission here at Otoy is to make all of that compute power practical, affordable, and easy to use for artists and creators everywhere. And to bring the magic of holographic rendering, which we define as 8D light fields, more on that later, to everyone, both on the capture side, the rendering side, the tool side, and even the publishing side. So when we talk about rendering, really a big part of that is, are we able to render reality? And so this is an NVIDIA contest called Real or Rendered. And spoiler alert, the image here is actually rendered by Raphael Rao, Silverwing, in Octane. And that's our software, OctaneRender. That's really the magic of GPU rendering. It delivers this incredible quality at this speed. And I'd say that a decade into it, we've learned a lot about how things have progressed in those 10 years and where the next 10 years are going to be heading. So we started off with Octane 1 with image rendering, ArchViz. A couple of years later, we added support for motion blur for things that are related to animations. And then pretty much around mid-decade, we started to see real production work using Octane. And for those that aren't familiar with what Octane does and the quality of its rendering for VFX work, let me show you this incredible reel from many media and opening TV titles and films that you may have seen before. Absolutely gorgeous work by many talented artists using Octane. This is one of my favorites. This is a frame from Ant-Man and the Wasp. That was one of the first Marvel movies done with Octane, all in camera. And subsequently, the opening titles for Captain Marvel, also done in Octane. And most recently, although this is not yet released, the director's edition of Star Trek The Motion Picture has scenes that have been rendered in Octane, and that's an amazing development. I can't wait to share more when the time is right. It should be out very soon, and when it is, we'll be able to share some of those renders. Now, the Octane ecosystem itself is not just the core renderer. There's about 25, 26 different 3D tool integrations really across the spectrum, from ArchViz to design, even After Effects and Nuke have plugins, and game engines as well. And that actually is where a huge convergence is happening right now in the industry. We're seeing enormous focus on real time, legitimately so, not just for games, but also for virtual production work. And so in 2017, we partnered with Unity. Octane's been integrated in Unity ever since. You don't really need a plugin. You could just load in content, and Octane automatically works within Unity Editor. And a few years later, we added support for Unreal Engine. which I'll be talking about specifically for virtual production shortly. So the last decade has really taken us from stills to visual effects to real time, and here we are at the quarter of the way through the 2020s, and it's interesting to sort of think about where things go from here. And a large amount of sort of angst is kind of happening now at an inflection point where both offline and real time are converging. The tools are changing, the platforms are radically evolving, both on the GPU side and on the CPU side, with ARM overtaking in many respects the x86 world. So the rest of this talk is going to focus on the future. I'll start by just recapping the last year of Octane's development. And Octane 2021 was a great release. It had a lot of amazing features for artists. We added support for geometry clipping. As you can see, it's real time, it's interactive, it's really fast, easy to use. Direct light sampling, 2 times faster, or in the case of progressive renderer, 2 times less noisy. We also leveraged hardware ray tracing for significantly faster motion blur with RTX hardware acceleration. And this is for instant motion blur. And soon we'll be adding support for deformable motion blur. We'll be showing that a little bit as well. We added a curvature node. You can see here the effect is really great for artists. And we took care of a lot of user requests, volume light linking. There was a 4x volume overlap limit. We got rid of that. We fixed invisible lights showing up in volumes. All of that is in the 2021 release. We also did some major work around AOV passes. That's completely revamped in 2021. There's a lot of flexibility there. You can use that with cryptomats, and it's been something that's been really great for a lot of work that happens from Octane into post-production. This image shows another feature that we added, which was a reduced shatter terminator function that's now controlled on a project basis. And we also added support for smooth surface tangents, interpolated surface tangents. This allows you to do much better anisotropic materials. And if you use a parallax occlusion OSL shader, that also now works much better. We also added native support for USD inside of Octane. That's becoming pretty much a de facto standard in the industry. We also took care of a lot of other smaller features in 2021. Multi-scatter GGX, energy preserving, that is in there. Random color texture node is in there as well. And we also brought Maxon C40 noises to all supported DCCs, not just Cinema 4D and standalone. A lot of the work around USD also led to the development of a Hydra render delegate. Now, Hydra render delegate allows you to take Octane and bring it into any app that supports Hydra, and that includes Houdini Solaris, for example, and also Omniverse. Omniverse just added support for Hydra, and Octane now runs within Omniverse. All the different apps that support that include Code and Create, and that's super exciting. We have a lot of really exciting announcements around Omniverse at the event today, and we'll be showing more of that. But one of those is an Omniverse connector for OctaneRender. And you'll see some examples of that a little bit later in the presentation. So let's talk about Unreal Engine. Octane for Unreal has been out now for about 3 years. And really, a lot of the focus initially was on providing path trace rendering, high quality path trace rendering to Unreal artists. And that's still the case. You can do final frame renders with no compromise, volumes, everything work inside of Unreal. And Unreal itself is turning into much more of a 3D content creation tool. So we're seeing that also with Unity, the acquisition of Weta. These things are all sort of converging to a single point, and we're tracking that very carefully. But internally here at Otoy, we're also using Unreal for virtual production work. We're doing a lot of work related to Star Trek. We'll talk about later as well. But you can see here, Unreal Engine is loading Octane, and in real time, Octane's able to path trace over the scene. Now, this doesn't mean that you can't change the scene. It's sort of a hybrid mix here. You're seeing both rasterization, reprojecting the Octane path tracer, and it's a really cool effect. Like in this case, you're able to just beautifully navigate through a scene. Now, you are also able to switch to a different mode where you could just have the brute force path tracer running the entire time, which is what you're going to see here. And it's a little bit darker, but it's still really fast. So you have these different options. You can also, of course, use Octane to bake the lighting. And you have this really seamless workflow between Unreal Engine 5 rasterization and path tracing in Octane, and shortly Brigade. So next I want to focus on the recent developments that we've been doing this year for Octane 2022. 2022.1 experimental build is out, and one of the best features in it is this new photon tracer kernel. We talked about that a little bit last year. We talked about a progressive photon mapping system for very fast caustics, but we ended up doing something a little bit better that allows us to have the benefits of very fast and nearly real-time caustics. And it is significantly faster. I mean, it's 1,000 times faster than what we had before, but it is real-time. It's fully interactive, and this is something we're extremely proud of. The traditional progressive photon mapping algorithm, the papers, don't really allow for progressive real-time rendering to work alongside of it, but in this case, we got that working, and it uses path guiding as well. So the quality and the speed is just fantastic. The other major feature, which opens up a lot of other doors to interoperability with other renderers, is support for Arnold standard surface. We're adding support for both volumes and material surfaces. We've been collaborating with Autodesk and Arnold for a while on this great project. You can see here basically scenes that are materially created in Arnold with Arnold materials just work and render correctly with the same parameters in Octane. And the Arnold standard surface is now a standard surface type in Octane. You can use it alongside of the existing materials, but it has all of the parameters that artists using Arnold have come to know and love. And Arnold standard surface is also a standard that's being proposed for the industry at large. So it's something that does work in Material X. See here, we support Arnold's subsurface scattering and random walk inputs, and volume absorption, emission, scattering, all those now work. We also did improvements in 2021 for black body volume emissions. That's significantly less noisy and higher quality in the new version. We also added support for taking a mesh and turning that into a volume, so you can turn that, you can take anything that's natively in Octane as a mesh, even procedural meshes, and those can be converted into SDFs and volumes for many interesting effects. And Vectron, which is our procedural shading system in OSL shaders, allows you to take those very same volume meshes and do all sorts of amazing effects with it. We've added support for Vectron scatter, where you can take a shape and you can scatter surfaces using OSL. You can even create shapes like this toaster purely in OSL with Vectron. And the modifiers are becoming extremely powerful, so we're excited to see what artists do with that in the coming year. We've also added support for textured specular anisotropy. That's also with the goal of having greater parity with the Arnold material system. We added the ordinary BRDF. It gives you improved diffuse roughness for any BRDFs that are not the custom Octane one. And we've also added other material inputs that are sort of renormalized to support what you'd expect from the Arnold standard surface. We also have a huge ecosystem of partner products and services that are extending from Octane, and that includes Kitbash 3D assets, Architron, which is for ArchViz, and World Creator and Embergen for procedural landscapes and terrains, and many other things that are connected to Octane. And so we see the interconnective hub of tools and products and modules that connect to rendering as being a fundamental piece of our future development over the next 5 to 10 years. Lightstage in particular is both an asset and a service and a technology. Obviously, it's related to scanning, but we're also creating metafaces, which are a library of hundreds of faces that you can feed into the renderer, and you can use that with many other tools and features that we're working on, including AI, retopology, and reprojection. Now, I want to talk a little bit about our work on real-time. We released Brigade Bench late last year, which is a benchmark for the Brigade render, a separate render that we developed many, many years ago and is now coming to fruition, that allows for real-time path tracing. And you can see here the test that we'd done about a year ago showed how well it was working. Now, this is not a spectral render like Octane. This was an RGB render, but it was still running really nicely at 60 frames a second. It was also a separate renderer with simpler materials. What we've done in Octane 2022.1 is actually have a mode that just allows you to use Octane normally. This is a full path tracer spectral materials, still a bit noisy, but it runs at 60 frames a second. This mode, no noise. This is a real-time Brigade kernel. You mix that with the real-time mode for all the other kernels, and you end up with basically noise-free path tracing, including random walk, subsurface scattering, all this running on a single GPU. This is running about 30 frames a second, but that's pretty good for random walk and SSS. And as we look at future features beyond just real time and all the things you've seen before, we look to the community, and a lot of the development that we're doing in the coming year comes from the feedback from users and artists. So looking at some of the other things we're adding after 2022.1, we're going to be supporting many more features on the Ampere GPUs. So we'll have 3 times faster particle rendering and 6 times faster hardware motion blur for deformable motion blur polygons and triangles. That's a huge speed up, significantly so for production work and VFX work. We also have a new denoiser that is about twice as good as what we had before. So that spectral AI denoiser in Octane is, best in class, and now it's even better, which is great. As far as the core work, there's always a lot of focus on stability. We're working continuously on figuring out how to make Octane run across multiple processes. You'll see some of that work shortly, and also a better error reporting system. And we're spending a significant amount of work and time on hardening out of core and memory support, both in NVLink and many other scenarios. There's also a lot of R&D that's being done on scene loading and scene sizes, and I'll show that shortly as well. We're taking some time to also focus on other user features for volumes. And for text vision shaders, we're still working on adding support for bitmaps. We're going to have a native parallax occlusion node, rounded edges node, which will be native. Right now it's a separate node type. It can't be used as a texture. That'll change shortly. Volume user data attributes, additive materials, rest position for Houdini. That should be done this year. And we're also working on other BRDF features, including a microfacet BSDF with tail blurring. And also, we're doing further work on our fabric BRDF, which I think will have even better quality results than what you're seeing here, which is exciting. On the AOV side, we're supporting light path expressions, and we're following the Arnold model for AOV drivers that allow you to export an AOV to whichever format you want right within the node graph. For post-processing, we've been doing a lot of work. We had a compositor that was built into Octane 2020.2, but we're working on a brand new imager node system and a GPU compositor, and this will go hand in hand with Brigade. Since Brigade is all running on the GPU, there is no CPU film buffer in the real-time mode. We want to have a GPU compositor that goes with that and allows you to leverage many of the other exciting features that are coming alongside Brigade. And that includes, for example, having AI filters that can run on the GPU, and they can be blended with cryptomat and other passes in the new GPU compositor. For rendering and motion sampling, we're working on improvements to the universal camera, including the ability to add masks and other overlays directly within the camera itself, and support for chromatic aberration that'll be both real-time and offline. Same with lens flares, optical zoom. And there are improvements that are being done around motion blur for HDRI environments and volume instant motion blur. These were pushed back a little bit into the 2022 release cycle just due to other features that came ahead of it, but they're on track for being done in the next year or so. We are also developing a time node that will allow you in the core system to create time shifting envelopes, super useful for proxies and Orbex exports, which are interchange files between the different DCC tools. And we're also working on procedural adaptive vertex displacement, which is something that we'll show a little bit of shortly as well. We're doing improvements to UVW packing, and this will be helpful in Houdini. And with Spectron, which is our procedural light system, we're adding 7 new light types. Those are in progress. including mesh lights, which will run faster than just pure emissive meshes. And then we're also working on a OSL-based procedural particle system in Spectron. And we can also support GLSL for things like vertex shaders from Touch Designer. Those are a feature that's been requested by artists for a while. And we're combining Vectron and mesh displacement. This is something that we've been prototyping for about 1.5 years, 2 years now. And the idea is that you can do vertex shaders like you would for a game engine, but do it really quickly and across many different instance types without requiring unique geometry to be stored in memory. So very powerful system being developed there. OSL trace sets are also in progress, material layer operators that are going to basically mimic OSL closures, which are coming as well. And this has been in development for a while, but it's still happening. Fluorescence and phosphorescence, polarized lighting, these are in internal builds of Octane, and we want to ship them as well shortly. So as far as third-party formats go, we are also looking to support Adobe's standard surface, which is similar to Arnold's, but it has support for other things, and it's, of course, a really big part of Substance. So SBS files are things we want to support directly inside of the render. That includes MDL graphs. And Material X in general, once that's finalized, whatever the spec that's going to be supported in USD, we'll support that in the core as well. And we're also going to support Hydra scene delegates. So Arnold USD driver, for example, takes anything in the Arnold scene graph and can spit that out as a scene delegate. That will actually be something we can support directly within the Octane scene delegate system that'll run in any of the DCC plugins. We're also bringing a unified IPR to Octane. This is some of the development work being done there from the C4D developer, and the C4D UX will be available in other plugins as well. Now, Multistream is a new system that we've been working on that incorporates things like headless rendering, but in a bidirectional way. So rather than just sending headless rendering commands to a server somewhere, with Multistream, we can actually link any two Octane processes together. You can actually run a NVIDIA card on an iPad, and all the GPU processing can be done remotely without a local GPU. In this case, we also have Blender and standalone interacting with each other, and you can change one or the other, and they'll reflect what the other DCC tool is doing. So live linking becomes really powerful. With multi-render, we've done something similar where we've allowed you to bring in any type of render into the core. And I mentioned that Hydra has been a big part of our development work. It still is. With multi-render, you can load in any Hydra render delegate. Here we've shown Arnold running inside of Octane Core. And it's really seamless. It translates all of Octane's materials into Hydra materials. It works also with Cycles, UE5, and Redshift, which are in development, and our internal renders as well. This is an early test version of the Brigade RGB kernel, and we have a animated renderer that is also fully supported as a render delegate that'll run inside of Octane through multi-render, and even independently, for example, here in Houdini Solaris. I want to talk about another project that's ongoing as well in the same vein, and that's MultiEngine. I'd mentioned that we could load in Hydra scene delegates, but apart from that, we want to develop things that are totally unique and original, that are essentially scene modules. Now, we have a tool called Sculptron, which we've been shipping for a while for sculpting. Today, with this system in MultiEngine, it can run entirely as a self-contained node, including its own UX. So you don't need a standalone app. You can embed an entire applet, so to speak, inside of the node system in Octane and edit it. And we're doing the same thing for Django FX's suite of tools, including Embergen, which you can see here. It's a real-time fire and smoke simulator. It's absolutely awesome. This will be available in all DCC tools through MultiEngine. The other exciting development that is imminent with our work with Django is other simulation technologies, including LiquidGen. First preview was shown here, which will do real-time liquid simulation. And like Embergen and like these other tools, this will be built into the core, and the interface for it will also be something that will be exposed inside the module itself within C4D or Blender or Unreal or any of the tools that support Octane. And the other exciting engine that we're adding in the core is Cinema 4D. We've licensed the entire Cinema 4D application from Maxon. It's a bespoke license. It even supports plugins, rendering plugins or C4D plugins. Those can now actually work in the core. When you're sending your cloud render jobs, you'll also be able to just send C4D files directly. So that's a really big development and one of the more exciting applications of MultiEngine. I would say on par with that is the full integration of Unreal Engine 5 inside of Octane Core. As you can see here, it's not just the Unreal renderer, the engine, and the physics and dynamics, but the entire editor, thanks to the great work from Epic. Starting with Unreal Engine 4.2.7, you can essentially turn all of Unreal into a library, and we're leveraging that to turn Unreal itself into a component that runs inside of Octane. And very useful, very powerful. The other fantastic third-party tool that we're supporting through MultiEngine is World Creator. It's currently a standalone app. Shortly, it'll be part of your Octane sub with a special version that'll connect to Octane. And this beautiful environment that you're seeing here is by Aaron Westwood. It's all created in Octane, C4D, and World Creator, and it's absolutely gorgeous. It's one of the most stunning virtual worlds I've ever seen. And this is the kind of power for artists that we want to deliver through this suite of tools. And World Creator and Octane and C4D are a great match. But it's amazing to think that you'll have all of these things really in sort of one single process. And as we look to other platforms, for example, the iPad where there's a single app, these kinds of things matter. So the desktop-based app nature of the world as we've known it might change significantly in the future as we move towards things that are in augmented reality, for example, where the app model and the desktop model don't necessarily exist as they do now. So beyond all these great innovations in the short term, what's coming in the next decade? That's the question I asked earlier, and I want to revisit that again as we look well into the 2030s. So we're at 2022, and I would say that the very first thing on this decade's roadmap as far as major features we want to cover are being able to load unlimited scenes. We talked a lot about the memory constraints of GPU memory and NVLink and out-of-core, but one of the technologies that we see as being fundamental is having unlimited scene streaming into VRAM. So this is something that we're going to be enabling through a technology called meshlets, hopefully this year. Meshlets are essentially Nanite for Octane. Now, Nanite is Unreal Engine 5's awesome streaming technology that allows you to load in assets into the game engine from disk. And we can do now the same thing, except this runs in a production renderer, and it runs with path tracing. And you can see here, this is a 40 gigabyte asset, and there's a buffer that's maybe 200 to 300 megabytes pulling in geometry and textures as you need it live. It's absolutely awesome. So you can forget about out-of-core system RAM, VRAM, everything really in the scene with this technology streams from your hard drive. And there's no more constraints on CPU or VRAM. It's really a fundamental change in the way that art and content can work. Now, you do need a fast SSD, but with direct storage and optics, direct access to the SSD, these things are all very possible. You can even narrow the buffer down and limit it, let's say, to 50 megabytes, and you'll get beautiful assets that fit within that window. So there's a fixed GPU memory overhead that you can set. Everything happens from disk in real time. And mesh and texture assets don't need to be processed in any special way. You can just load them into this system as is. Now here's a massive 128K by 128K texture being streamed in live in real time. Also, even though you don't really see it, here it is being path traced. And this is amazing. And this doesn't have to just be for textures. It can also be for displacement. Those displacement textures could also then be modified. So you're seeing the beginnings of a really, really powerful system. Again, resource limitations disappearing, hopefully this year with meshlets. Now, next on the list of advanced features that we're targeting and we think will be fundamentally important in the coming years is AI neural rendering. So neural rendering is essentially right now its own kernel in Octane as we've tested it. You can create a AI geometry object, and it is essentially purely AI. You have to train it, But what you do is that you can feed it something that's either rendered or photographed. And in the case of something that's rendered, we have an automated system that just runs a render job. It can run it on the render network, or decentralized blockchain system, and it'll give you back an AI object. So this is the training part. It basically then gives you an output that is a neural object. This is not a volume. This is not a mesh. It is something totally different, and it renders with all the properties that a real 3D object would, except it is an AI system. And what's great about this is that you can do AI filters. You can generate things that are purely neural network based and mix that with hardware ray tracing with anything. So we look at this as a fundamentally new asset type. And essentially, we don't even know what artists will do when they have the ability to run training data sets on things that they sort of create together, collaborate, and then share. I mean, just the idea of mixing nodes for materials and OSL shaders has been a very dramatic, creative explosion. With AI in the node system and this kind of technology, I think we're seeing the future of how rendering and content creation may very well work for a vast number of artists and creators. So next on the list is something that I've talked about in the past a lot, which is Web3, the blockchain, and how that relates to both rendering and augmented reality, mixed reality, is pretty important. So we launched the Render Network 5 years ago now, and it was out of beta in 2020, so it's now about 2 years old, and it gives you distributed rendering power. There's really just this massive amount of GPUs out there, and we want to harness that to deliver really cheap rendering power on demand, and it works. Our very first customer, John Knoll, legend, it was amazing to see that happen. He did a render in about an hour for the Hayden Planetarium, and he was under an incredibly tight deadline. And that's true of so many of the users in our space. We've had great results with artists on render. We're super excited to keep developing it, especially with the technology that we're bringing in with partners like Autodesk, with Arnold support on render. Now Maxon has added to that with Redshift. Redshift will work on the render network. You'll be able to render in Octane, Arnold, Redshift, and others as well, including leveraging anything in Cinema 4D. All of this runs on the decentralized nodes on the render network. We previously announced that Google and Microsoft have joined the render network. They're providing all of their GPUs as much as we can add to the system, and yet we always need more capacity, and we want to develop whole new workflows that are leveraging all of this compute power. You saw earlier the AI neural networking system depends heavily on GPU power for training, not just for rendering. So the Render SDK is what we've been using to develop our own tools for the render network, but you can build your own applications. And of course, some of these things are siloed. For example, building a scene or render delegate is fairly straightforward. Those APIs are almost built on Pixar's Hydra system, but there's more that we can do. And we want to develop a system that allows you to build things that are both on the GPU and CPU and on chain. So that's a big part of how we see the metaverse happening in the future. I use that in quotes. Well, I know that word is sort of loaded these days, but our partnership with Solana, which is one of the top blockchains out there, started in earnest last year. So Solana is different than Ethereum. And one of the reasons why we picked them as a partner for a lot of our future work in development for the Render SDK is that we want to develop smart contracts on chain that are written in Rust and that can run on the GPU, the CPU, and inside of the Solana VM, which is also Rust-based. And it also does allow you to run C++. So Solana is amazing because it's very fast throughput, high security relative to side chains, and it's easy to do payments. It just solves a lot of problems. And also, they have a great team working on the NFT ecosystem, which is a big part of the artist workflow on the blockchain that we see happening with Render. Metaplex, the team there, has been absolutely instrumental in helping us rethink how NFTs could work through Render. And so with Render and Metaplex, we just see a lot of totally new avenues opening up. Custom 3D metaverse NFT stores are fundamentally important. People want to build that inside of their art. Dynamic NFTs. I mean, these things are not really easily done today with traditional NFTs. And we're hoping that with the Metaplex partnership, we'll be able to bring that and much more. People want to have live dynamic NFTs that are streamed, frictionless. So we'll be showing a lot of that technology. And if it weren't for Metaplex, I don't think we would have had a partner that could really push the envelope in showing examples of how this could work on chain today. And they've been really great. I mean, our sort of last 5 months with them has been explosive. Can't wait to show you more. The most important point, though, is that if you're developing GPU code, you can actually target that in a smart contract as well. I mean, that's the beauty of the Render SDK working with Solana, working on Rust. And I think that there's no way that the future of content and provenance is not going to be decided on the blockchain. It's not just cryptocurrency tokens. And with a partner like Solana and with the future of GPU code itself being something that's going to be mixed across different device types, I think the future is pretty great for blockchain-based authoring and validation of GPU code. So NFTs, I touched on that earlier. On Render, we definitely need to think about that because everything that you're creating on the Render network is already an NFT. We've got artists using Octane for a decade, like Beeple, put Octane on the cover of Time magazine and made $100-something million last year. Pack as well. These are top artists, and they're using the tools that we're creating to deliver, art that people want and that is truly original. Pack has declared himself the most active user of the Render network. I won't argue with that. He's been rendering his NFTs on chain on the Render network. It's being done by nodes that are on the decentralized system, and they're creating this amazing artwork. And some of these pieces, like the Merge, $91 million. It's absolutely crazy. But the future of crypto art and NFTs is dynamic and procedural. I mean, Pack's a genius. He creates these amazing systems that are, I think, really a perfect match for what we're doing with Render. The idea is for any artist to be able to take any part of the rendering chain, textures, assets, anything in the node graph, and essentially link that on chain through a render job to an NFT. And once you've done that for, let's say, an offline render or finalized art, those validated assets can then be brought into an interactive stream. And this is what we've been doing with Metaplex. We can load in a real-time stream. This is powered by Unreal Engine. All the assets have been basically rendered offline before they can load into Unreal or Unity or any other tool. And you get an NFT that is dynamic, that is streaming into a browser. And that stream works inside of the NFT marketplace. So instead of having an image or a video file, you can have this. You can even have apps, like I was just showing Octane. It can be Blender. I mean, essentially anything that can be coded inside of the Render SDK and the virtual machine will work. And we've been doing for many years now tests to essentially create shells around Unity, which you're seeing here on the right, and Unreal, which you saw earlier. I mean, that's going into the Octane core. So your Unreal Engine projects, your Unity projects, your apps can all be turned into streams on chain. And in the case of real-time streams, I think the concept of mixing something that has previously been validated, proof of render, as an offline render into it, and that dynamic scene wrap probably solves a lot of the complexity of dynamic verified blockchain metaverses. And we've also worked with many other partners like Decentraland. They're a Unity-based virtual world. And more exciting than all of that, I think, is the focus on devices that Render is providing this year. We've previously shown some prototype work for the iPad and iPhone, but we are building a whole new Render app that'll connect to the Render network and give you 1 GPU of local rendering power with Octane. There's a new interface. It's actually really awesome. I mean, this is an iPad that allows you to set up a scene, do the lighting, all on the device. And when you're done with this, you can send that scene to the Render network, which will finish everything else for you. But having tens of millions of iPhones and iPads that can basically get into this Octane ecosystem is just fantastic. That also is an important consideration as we look towards AR and mixed reality. So having something on an iOS and iPad device means that we can start to use our real-time workflows and our offline workflows for mixed reality right in camera. These are some of the tests we've been doing around using the Octane, now the Render app on iOS live. We can use tracking markers, we can use ARKit, but having this kind of control for artists and for virtual production is fundamental. We've also focused heavily on making lighting work really well in real time, even just with the iPhone cameras, which is what you're seeing here. And that's tough to do any form of interpolated ray tracing, especially when you have a very shiny object like the one you're seeing here, which is being rendered live, is difficult. But this is being rendered entirely live, on the iPhone, and you can see here there's an emissive surface that's reflecting off the object. So we're essentially doing, ray tracing from the scene, depth estimation, all of that live, and compositing that inside of the app. Now, if we want to take a production scene like this one, we can do the same thing. We can bring that into the app and get it to run with animation in AR. There is sort of a full offline mode, and then there's a pre-computed live mode that is suitable for this kind of really high-quality cinematic filmmaking. This is all running live on the phone, and there's motion blur, there's shadows, and it's pretty great. Let me show you an example of motion blur, which is right there. The reason why we're doing this is that there's a ton of viral videos like this one that 10 million views that have been done in Octane, in this case, Octane for C4D on the desktop. And I know for a fact that if we were able to bring this technology to the phone and you're able to do this directly on the device, you'll see this kind of stuff be so much simpler and easier to do. And remember, when we're bringing the applications to the devices, you'll have, for example, all of Cinema 4D's engine inside of our iPhone app. The render network will be there to finish these final frame renders. And these are just amazing things that have been done with mixed reality offline. This is a very recent one done on TikTok, also using Octane for C4D. But the idea of delivering this through phones is really exciting. I just feel that that's a fundamental use case for how Octane and AR and the render network will be used together. This is another great example. Here's an offline render on the left. On the right is the same exact scene file running live in AR, and it looks pretty great. The effects you can do live, for example, are pretty compelling. You can do dynamics and physics, and this is all running again live. So you can basically just hit record and you've got a beautiful scene. So as we look beyond all of this blockchain technology in the Web3 space, I would say that the next major piece coming this decade would be holographic displays. Now, the ultimate goal of a holographic display is the Star Trek holodeck. As those who may be familiar with Star Trek may know, there's a room on the Enterprise where you can go into it and it can recreate reality perfectly. Now, that technology is not hundreds of years off. It's being developed by a partner of ours called Lightfield Lab. We've been partnered with them for many years now. And the technology they're doing is awesome. I mean, it's actually shipping this year, probably for location-based entertainment venues first, so concerts, but eventually it'll be in things like museums and displays and stores. But I think one of the great use cases for this will be tabletop holographic displays with touch and other input. We've been testing how these displays work locally with the projector and shutter glasses. I showed this in previous GTCs, but the displays themselves don't need any glasses. You can look at the holographic display from any angle. You have horizontal and vertical parallax. You can tile these displays together, so it's like the Samsung video wall. The larger the volume in and out of the surface that you want, the more tiles you add. Both width, height, and depth are extended every time you add another tile. It's pretty cool. And for the first time, I can finally show what this looks like. So the big public reveal of the display was last fall, and this is what it looks like. Now, of course, you're recording this with a camera, but as you're moving the camera, you're seeing parallax, you're seeing specularity on this holographic object. Just the iguana is real. The rest of, sorry, is hologram. The rest of it is real, but it's absolutely stunning. And it's pretty enormous display. I mean, it's basically about 40 gigapixels, and it's a lot of compute power. So to drive this, we just need about 1,000 times more than 4K HD requires. And the render network can do that for offline rendering, but for local rendering of holographic displays, we need about 16 times the GPU power. So again, something that we see happening maybe mid-decade, 2027, you'll be able to have this kind of compute power baked into every one of these display panels. Now, the next section that I want to talk about is the metaverse. I mean, it's obviously something that's on people's minds. As I said before, maybe the word itself is kind of loaded these days because of the excitement around, I guess, Facebook rebranding itself to Meta. But I've been thinking about the metaverse for ages. I talked about in this blog post, what is the metaverse really? And that's a question that people still ask themselves. But from my perspective, I think the metaverse, of course, is a 3D spatial web, but it has a purpose for creators and artists that I think is really important and fundamental. And that is to archive your art and to give you this chain of authorship that is there forever and that can be used to define what you've done in the world and allow others to connect to those very same dots. It's something that, of course, now has a lot of value with NFTs, but the idea of archiving an entire lifetime of work is something that we have been testing. I teased this project last year, the Alex Ross archive. Alex Ross is an amazing comic book artist, been my friend for ages. In fact, created a book called The Unseen Art. There's a whole chapter on the metaverse mentioning this project. And the idea is that every single painting he's ever done is a story, right? In certain cases, they're actual comic books or publications, and they're all interlinked. So just like the web links pages together, these stories, these assets are linked together spatially and in 3D. Now, of course, he's a 2D illustrator, but we've taken all of his paintings and we've rebuilt those in 3D. There's a scene graph, there's a description ontologically for all of these different files and assets. For characters, we've either built them from 3D, or in the case of certain characters like Norman McKay from Kingdom Come Here, we've light staged them. There are characters in the Marvel Universe, for example, based on myself. So again, the ability to create 3D characters and start to create an ontology around them is where the Alex Ross archive has been absolutely exemplary and given us a lot of early ideas and thoughts around how a metaverse that is bent towards the idea of storytelling can work. Now, there is some work that's also been done on chain around this concept. And we created a token called MS for Metaverse, just a single token that is a staking token, and it supports about 100 million different human concepts. So if you're creating a piece of art inside of the Octane node editor, you can now pull down this node and you can pull in concepts for the Earth, stars, anything. And if there is an asset or a graph for it, it'll be connected to it. This is great for linking what you say the Earth is to your 3D file. And there is a voting system or a DAO that can say which is more, true, or which has higher fidelity. That's how DAOs work. You can say the Earth is flat, or you can say it's round, and presumably rounder Earths will get a higher vote. There is a lot of exciting possibilities, though, when you look at it from the storytelling perspective. Every story that Alex has told in the Marvel or DC universe becomes a piece in the blockchain, and you can link to it. So one of the first things we did was linking the Roddenberry archive, which I'll be showing shortly, Beeple's archive, Alex Ross's archive, with essentially what's the narrative index, what's the Dewey Decimal System for each of these stories, each of these pieces. And there's a list of about 1,000 parallel Earths that are numbered based on the Marvel Universe system, and these are all on chain, and these are all just one little thing that you can do with the ontology of tools and data points inside of this side of the system. It's like the IMDb of the metaverse, even the Omniverse, which is NVIDIA's name for their amazing virtual world system, maybe their own metaverse, so to speak. Turns out the first appearance of the Omniverse was in Universe X by Alex, so that's indexed in his archives as a narrative world, even though it connects all worlds together. Now, with Beeple, the archive that we're doing with him is much different. In some ways, everything that he's doing is self-descriptive. So he's, of course, making NFTs that are done in Cinema 4D and Octane. But what we're doing is almost reverse engineering that with the archives. I mean, everything that's inside of the C4D file, the Photoshop file, we're sort of allowing all of that to exist as he's creating it as a render archive. So when an image that's already out there, even one that's already an NFT, needs to be, I guess, deconstructed or proved or verified, all of the data is there on the render network just by essentially resaving the C4D file, even the Photoshop file. All of those pieces together essentially give you the original source. And again, the fundamental concept of having objects or graphs be, I guess, what you'd call an NFT or an item on chain is very different than the current conception of NFTs being, a fixed asset or a non-dynamic, pretty linear, output. This is where I think the future of collaborative works and other things can happen. Of course, NVIDIA Omniverse does support a lot of these things as well, and we'll be showing that as well. This is the same asset rendering live in AR on the iPhone. The idea of creating this asset once and having all these different things in the future generated from it is a big part of why the render network and the system that we're building is important for the next decade. We have no idea really how things will develop when you get into mixed reality, holographic displays, brain-computer interfaces. These things are also, incoming. But what's fascinating about working with Mike Winkelmann people is his focus on the physical. He's done a lot of work this past year on physical displays. And there's no doubt in my mind, and I think in his, that when the Lightfield Lab displays are ready, a lot of his physical pieces will leverage that, and they'll be pulling things down from the render network for those holographic panels. And I think NFTs, art in the future, this is what it's going to look like. So the third archive, and the last one I want to talk about today, is the Gene Roddenberry archive. This is a special one. I grew up in the Roddenberry household, and Rod Roddenberry, Gene's son, is my best friend, and his endowment is what allowed this project to happen. And we launched it officially on the centennial, on Gene's 100th, or what would have been his 100th birthday. And the archive's amazing. It's really, of course, if you're a Star Trek fan, Star Trek is a huge part of Gene Roddenberry's work, but the archive itself covers everything he's ever done. Every letter he's written to other luminaries, Steve Jobs or Carl Sagan, Isaac Asimov, these are all part of the archive textually, but also, as we're doing with Alex's work, visually too. The story of Star Trek is something that through millions of documents in the Roddenberry archive can be told. But what's also exciting about this project is that when we can, we're creating 3D assets from the blueprints, from the people that worked with Gene, for 50 years. And one of the key pieces of this archive is a life-size enterprise. I mean, we have the production version, the Smithsonian 11-foot model physically is represented in this system, but a life-size version is something that people have dreamed about and want to see. And it's something that really is a labor of love and lots of years of work. As you can see here, what's been done so far, about 4 years of work. The interiors of the ship, they're built, and you can navigate through them. We're even building the entire solar system, planets, everything. It's a massive undertaking, and it's a big part of us figuring out if we can do the Enterprise, if we can tell the story of Star Trek in the metaverse, then a lot of other things in the metaverse can use those very same templates and do the same thing. And in fact, the correlation of Alex's work, Beeple's work, and even this work for the Roddenberry archive really is to sort of prove that point. But looking just at the asset itself, I mean, this ship is just gorgeous. I mean, this basically is what you'd see in the films, but inside of that ship is an entire fully working system, entire shots and sequences from the movies, the TV shows. Every time the Enterprise appears, there's a data point in the archive. We can match the camera to that. We can make it all work. You're seeing here, there's a little bit of splashiness around the stars. We're replacing that star field, which was a 64K NASA star field, with the actual 80 gigabytes worth of star data. So we can do that procedurally, all on render. You also have a procedural Earth, which you're seeing here, moon, everything. The inside of the ship, the interiors are just, absolutely fully detailed. This is the recreation deck. As you can see, it's pretty much identical to the one you'd see shot for shot in the film. And the interior of the ship is not static. I mean, it's full of life. And you can see here the warp core, which you just saw briefly from the cut out of the ship. Inside, you can walk around it. You can push the buttons. It's moving. It's all there. And this isn't really about the programming of an interactive experience. I mean, this is part of the artwork itself. The ship works. The physics work. Everything is there. And the magic of verisimilitude and art, I think, is represented really pretty well by this project. This is the inside of the bridge from the 1979, I guess, design of the bridge. Had changed over the years. But again, everything works. The sounds, all of it's there. You can turn it off, you turn it on, the doors work. You can push a button and things will pop out. This is what you'd expect, not just in a museum, but in the real thing. And the idea of digital twins for something that's as beloved as the Starship Enterprise, which is why it's in the Smithsonian, is why I think the metaverse as a form of art has a compelling utility. This is another beautiful render. This is from Star Trek II. And you can see here, shot for shot, we're matching the renders from Octane in the project to the original camera angles from the films, and it's super, super close already, which is pretty exciting. You can see here the wireframes for that shot. And speaking of wireframes, the entire design of the ship is being done in collaboration with Lord Johnson, who's the expert on every single room on the Starship Enterprise. And we're also going beyond just one version of the ship. All the prototype versions of the ship, every design is being recognized as well. And when you look at the world line of the Starship Enterprise, it's enormous. The Star Trek story itself takes place over 1,000 years, and most of it, of course, in the 23rd century, like the original TV show. But just taking the original Starship Enterprise and going through the 40 years of its renovations, I mean, you're seeing here the different seasons, it's really fascinating to see. And there is, somewhere in the middle of the Star Trek movies, they swap to a different ship, Star Trek V, Star Trek VI, but it's all there. And there's actually 8 different canonical Starship Enterprises that are built one after the other. Some of them are previous to the one on the original show. And if you count other universes, other timelines, there's about 14 of them. So we've got to work it out for us. Some of them are precursor ships, and others are in the far future, like the one at the bottom there. It's the Enterprise J from Doug Drexler, one of the curators on the archive. There's an entire city in that ship. It's gorgeous. The Enterprise D, the future ones, of course, are very visually different. But I'll use this to show an example of a future Enterprise ship, the Enterprise E. This is being shown in Unreal Engine. Of course, we can also split this and render it in Octane. But the beauty of these assets is that you can actually go through time, you can go through space, you can go 5-dimensionally through parallel universes and slice the story of Star Trek any way you want. And that includes sort of a nod to platonic modal reality, where what happens in the fictional universe of Star Trek also has a connection point back to the real world. A lot of these assets come from physical objects. This is Planet of the Titans, an early version of the Star Trek motion picture. This ship has a physical model that was donated to the archive. We scanned it on the left and the light stage. On the right, you're seeing the beautiful render in Octane being done live. And I have to say that seeing a scanned object like this rendered with all the imperfections from the model in there, it's pretty great. And we can also, of course, improve that digitally, but we have everything. There is no one specific asset for this model. We can have 5 or 6 different versions that represent the in-universe version, the scan version, what's on Earth. But the scans are important. I mean, those represent our ground truth. And whenever possible, we do want to use Lightstage to deliver, really high fidelity, perfect scans of any authentic asset. And these are some of the other ones that we've been working with. These are at the Skirball Center, and they're owned by the Paul Allen Estate. We've been working with them to scan in these assets for a while now. You can see our team here behind the plexiglass. This is the original Starship Enterprise console and chair, and Kirk's uniform and Spock's uniform worn by Shatner and Nimoy. Scanning these things is really scanning in history, and it's important that these things get preserved. This is the actual Enterprise D 6-foot shooting model. But we can also, as I said earlier, create these things digitally. And in this case here, we almost don't need the scans, although we want them, of course. We can create just absolutely incredible fidelity versions of these props. These are all digital, done by the amazing art team working on the project. All these are authentic props and rooms from the original series. The detail is phenomenal. The felt on the carpet, perfect. The details in Kirk's room, the globe on his shelf, it's all there. You know, the knitting. And in the case of rooms that had lights or mechanical things that you saw in the show, you can basically recreate those and see those. I mean, even for example, the showers and toilets on the Starship Enterprise in Kirk's room, they work. It's all there. There is literally nothing missing from the ship. And that's what's exciting about having a digital twin, or the verisimilitude of imagining if you're both playing a game or telling a show. I mean, there's nothing missing from the world around you in the set. I want to touch a bit on what I showed earlier with the NVIDIA Omniverse connection to this project and to our work. NVIDIA Omniverse is a fundamentally important platform, I think, for the future of metaversal art and content creation, and we're excited to partner with them. We're leveraging Omniverse for a lot of the things we're doing on the Roddenberry archive. There's an easy connection, of course, through Unreal, which you can see above here. There's an Unreal Omniverse connection, but we're also building a direct connector to Octane and the Render Network, so that essentially any of the 26 DCC tools we already have, plus anything that Omniverse connects to, which is its own thing, they work together. That's the future of these sort of networks where, you know, it's not a zero-sum game. These things all add together. And especially when it comes to some of the things that Omniverse has done really well in their kits for interactivity and multi-user experiences, we want to leverage that heavily for this, for future developments on this project. Now, there's also a lot of 3D tools that, as I've seen before, Omniverse brings into the fold. Those will now work with all the other pieces that are inside of our ecosystem. And we also want to see open standards develop around USD. We're working closely with NVIDIA on, and others actually, around figuring out how to get USD and the other pieces into a single unified open source standard. Very important, of course, for fundamental fabric of an open metaverse, an open spatial web. USD itself is a great starting point, but it's not the whole system, so we need to do more. The other really great part about the work with NVIDIA, and this is an important piece, is that everything you're doing in Omniverse can benefit now from the render network. So if you want to validate your Omniverse work on chain, on Solana, on ETH with the render network, you can do that. You can run a render job. Just running that job, even with a different render than Octane, essentially validates that system. All of the from Metaverse tokens, the pieces, you want to name your world, your ecosystem, you want to do fan fiction off of a Star Trek episode, bridge it to the real thing. It'll all be possible with this system, and working with the team at Omniverse has been really compelling and rewarding. Now, I want to talk about storytelling, because that's important. We've talked a lot, and we've shown a lot about characters and, not characters, but more of the sets and the ships and the locations. But the characters are an important part of Star Trek. And here we've got an image of Spock. Before I put this in my deck, I shared it with Adam Nimoy, the son of Leonard Nimoy, the actor. Now, this image isn't a photo. It's a synthetic render done by our art team of Spock. This is the kind of quality that we want to bring to the render archive. Same thing with clothing and uniforms. And why? Because we want to be able to tell those stories or record, the history of Star Trek, including, the episodes that aired with characters, with those sets. And we're starting from the very beginning with The Cage, which actually was 2 years before Star Trek aired on TV. It was filmed in '64, directed by Robert Butler. And rebuilding this episode, that's the genesis of Star Trek. That's ground zero for us. And we're using a lot of techniques to do that. We have all of these sets that we're using with virtual productions, LED walls and the like, so that we can actually film things that we want. We can actually have the director, Robert Butler, on location inside of the very world that he directed 56 years ago. And the costumes and uniforms and the hair are things that we're building both physically and digitally. We are using Marvelous Designer for this uniform. We're then creating the fabrics and the prints. Physically, we're correlating those together. And the idea is that we end up with everything that we need for the character to be embedded in the scene. And as we look at the sets from that first episode, I think we're going to get extremely close, almost perfectly so, I think, to what was shown on screen and go from there. The sets, of course, that we have in the virtual world are in some ways even more detailed than the ones that were made out of plywood and that sort of ended, right, at the end of the hallway. I mean, these don't. These are all completely cohesive sets, but they're made to match and look exactly like the originals, which is pretty phenomenal. We're really proud of the work that the art team's doing. I mean, this is incredible. This is what we're going to be using in the virtual production stage. This is fully working Star Trek Enterprise interior, and putting in the director of the original episode and performers that we can then synthesize. And of course, performances are important. It is art, just like anything else. All of this, I think, is an important key to the future of storytelling and the future of filmmaking. And I do think that, coming back full circle to the future of rendering, we're seeing that a lot of these elements are going to be in the hands of a lot of people. Virtual production is something right now that, yes, requires LED walls, but the virtual worlds is something that we are seeing coming into the hands of a lot more people. And I do think that as augmented reality, mixed reality, the cloud, the render network, all these pieces come together, you're going to see a lot more storytelling and a lot more work being done in mixed reality, taking all the best of the things that we're seeing with virtual production. But for sure, films and TV shows, I mean, we're already seeing that with The Mandalorian, they're going to converge. And I think that the tools that we've seen to date are going to radically be altered by the kinds of creators and the tools that are at the disposal of all of us. So again, super exciting. And as Gene Roddenberry would say in closing out, we think the human adventure is just beginning. Thank you so much. This has been the future of rendering, and this is Jules Urbach signing off for GTC 2022. Thank you, everyone.